So a few months back when we were all starting to talk about different presentations, it became obvious that we needed to do one on Azure because we had some projects coming up that are now in progress. So it seemed like we needed to have a talk about it. And then over the last couple of months, I've been stopped a number of times in the hallway about what is this and what is that, different parts of Azure. And so I decided to go ahead and prepare this presentation, but it's not a code demonstration at all. It's going to be more like the name says, what tools do we have available to us that we may be using at the moment or may not be using that may come in handy on current or future projects. So we're going to go over what the different cloud vendors are and some terminology, just to, because there's different people in the audience that have different levels of experience with what cloud is and what the different terms are within cloud technology. Why use Azure over other vendors? There's many different reasons, and we'll go over a few of those. What tools are available to use in Azure, and at the end, some artificial intelligence. So first, the major cloud vendors, of course, Amazon. Everybody knows Amazon, AWS, Microsoft, Google. IBM just recently bought a company called SoftLayer, which is their attempt at doing cloud. And then you have companies that are typically not thought of as cloud, like Rackspace and others. We'll go into some of that in a minute. This whole industry has been changing drastically over the last few years. If you look at this one from 2015, it shows that AWS is at 57% utilization, where if you take the two parts, the Azure IaaS and the PaaS together, they're like 21%. But now you jump that 2 years, and now Azure's at 28%. And Azure's gone, AWS went from 57 down to 37. So there's a lot of shift going on, and there's a number of different reasons why that. We're going to go into some of them. So first of all, let's get some of this terminology out of the way so that we kind of are on the same page on a lot of these kinds of things. So you hear the terms public and private cloud, and you wonder, what does that mean? And you have all kinds of salespeople throwing these things around, and you're like, do you really know what you're talking about? So the public cloud, resources are housed, configured, managed by a third party usually, like one of those vendors that I was just mentioning. And the traffic to and from those goes over the general public internet. Whereas with a private cloud, there's different forms of it, but resources are hosted by a third party usually, more like a Rackspace or even other local providers. But the traffic to and from those goes over private leased lines. So they're very different architecture in that way, mainly for security reasons, that a lot of them do that way. Then the next, so it's, do you want to maintain the hardware or leave it up to someone else to maintain? Now, infrastructure and platform as a service, those are two other terms that get tossed around a lot. And I wanted to go over what the difference was between those. With IaaS, a third party manages the physical hardware. You manage the operating system and everything below it. So you have to maintain the operating system, do all the licensing and upgrades that are concerned on that, do backups, disaster recovery, scalability, all of that are your concern, and you have to be tightly involved in controlling that, especially if from a consultant standpoint. Letting the customer know what the differences are between these and what that impact means to them. Do they need to have a person on staff that actually can maintain that and knows how to do it? Now with platform as a service, the third party manages the hardware, the networking, the routing, OS upgrades, security upgrades, all of that stuff gets handled for you. And you manage the applications and everything that's running on that. you manage the application data, and then you set limits for scalability, because many of these have the capability to automatically scale up and scale down, and you can set limits primarily based on how much you want to spend. So if you've got a website, you put it up and you get millions of customers all of a sudden, and you have that uh-oh moment. If you have a set budget, you can usually set what that limit is so that it doesn't set you back. So, again, just like with public versus private cloud, maintaining on IaaS and PaaS, you're maintaining the operating, or they're maintaining the operating system, and you don't have to do it yourself. Then the fourth level is SaaS, the software as a service. Typically, when you think of that, it's one where you're just logging in, using an application, and as a consultant, all you're doing is controlling configuration and users and that sort of thing. So think of, you could even think of Office 365 as SaaS, or most things from Salesforce, that sort of thing. So, why would you want to use Azure over some other third-party vendor? And there are a number of different reasons. I'm just going to go over a couple of them. This is by far not an exhaustive list. So, as the real estate agents always say, location, location, location. That's one of the prime advantages that Azure has over many of the other ones. They have 34 regions around the globe. And when I say region, a region is usually made up of at least one data center. And if you think about these things, a data center usually costs between $750 and $1.5 billion. 750 million to $1.5 billion to put in. And they have 34 of them. And if we look at the globe, they're all over the place, including some that are in progress of being put in, like the ones in South Africa. These are actually going to be the first data centers in Africa. But they have, also notably, are the two in China. They're one of the first vendors to actually have Chinese-based data centers. But if you look at the US, there's all kinds of them, and they're putting in more. And there's a couple other ones in there that are designated a little differently. We're going to get to that in a minute. So the other reason is compliance. One of Microsoft's major pushes with Azure has been to make this a platform that customers would be fine putting their data on, and not just corporate entities, but also governments. So they're really concerned about having the right things in place, both hardware and legally and otherwise, in order to handle many different scenarios. So they have been really at the forefront of making sure that their systems are compliant with many different standards. You'll notice that the hard one right there is the third one, the DoD compliance. Yes, the DoD actually has some of their stuff on Azure. Then we come into what are called government clouds. So with government clouds, there are some specific requirements that governments have, as well as specific requirements they put on the public cloud. So even for these 34 data centers, if you look back at it, there are two, for instance, in Germany. And then there's a whole bunch in other parts of Europe. The EU is about to, or already has passed a resolution that goes into effect in May of 2018 that basically says that under this law, any company that deals with private individuals' data in the EU, having to do with an EU citizen, even if that company is located out of the EU, must follow the guidelines. So that means if one of our customers has data about an EU citizen, that data can only reside in the EU. It can't be in the US data center. So it's some things that we, going forward, if we have customers that get into the international market and that sort of thing, that we need to be concerned with. And the problem is the penalties for not complying are 20 million euros or 4% of your annual sales, whichever is greater. So it's stiff. So, needless to say, like with Germany, they don't allow any company to store data about an EU citizen outside of Germany, a German citizen outside of Germany. And they have really strict laws about that too. And there's a number of other countries that are beginning to do that. But if you go back down to where we were. So the big concerns are data sovereignty. There's currently an ongoing lawsuit going on between the US government and Microsoft about some data about a particular user. And the situation is that the data in question is an Irish citizen. And it's in an Irish data center. But the CIA wants access to the data. And the government has subpoenaed that data, and Microsoft has said no, and it's actually either just about to or did just go to the Supreme Court. And it's gone through a couple levels of legal action. Microsoft saying it's not in your jurisdiction to get that data, so we don't have to provide it to you. And Ireland has already backed that up and said, yes, we don't. If you follow our rules, you can't give that data up. So there's basically Microsoft is saying, you need to go through State Department and determine this between countries. Leave us out of it. But, of course, CIA is not doing that. So, the other thing with government clouds is they have to be physically isolated. So they cannot be connected to the regular internet. So if we look at this map, if you look on the side, there are a number of them. There's DoD East, US Government Virginia, DoD Central, US Government Texas, and Iowa and all that. Basically, they're whole data centers that are just dedicated to government, and they cannot be on the regular internet. Another big thing about that one is all personnel that work at those facilities have to go through government security clearances. So that's another reason that they have to be totally isolated. So these are just some things that I wanted to bring up that as we get larger and get customers that are global, and I know some of ours currently are going to be going global. So these are things that we need to be cognizant of as we go forward in our design.
So how does that differ from Amazon? I know Amazon has government regions, so to speak.
They are going to have to comply with the same regulations in order to even get the customers. So there's lengthy security audits that they go through before any service can be put up on there. So Amazon, if they're trying to get into that market, is going to have to do the same thing. So the other reason for using Azure is ease of use. I know from a couple of different projects I've been on here, both using AWS and using Azure, from a developer actually putting together the sites, putting them up, getting them actually working. Azure is, on one project we were on recently, there was multiple days trying to get basic services up on AWS, and the same thing on Azure would have been much less time. Also, when you provision something, so for instance, on the portal, one of the things they give you right there is a way to download a PowerShell script, so you could replicate that over and over and over again, but you don't have to come up with what's this cryptic command line that I need to do it. They will actually give it to you so that you can automate that. And then there's PowerShell. If you know PowerShell and can understand what they're doing with it, you can manually do everything that you do on the management portal with PowerShell. In fact, behind the scenes, that's all that's happening, is that the portal is translating everything you do with drag and drop and all your different capabilities on the management portal just gets translated in PowerShell and covered. Now let's go into a couple other tools that is available on Azure that either we're using and maybe not using to the full extent we might be able to, or tools that we aren't using yet. So first of all, I'm going to be covering these in those same IaaS, PaaS, and SaaS classifications like we were going through before. So the first one that we all are familiar with as VMs. Now, they have pre-built configurations for different VMs on Azure. So you go into the portal, you say, I want a new VM, here's the OS I want, and they manage all of the licensing for you, or you can pick, I want to bring my own license. So you've already got your own license, and you want to put it up on Azure, you can put in the licensing information, and they will use your license on your VM on the cloud. The next one is container hosting. We've done a little bit of this with a couple different projects, but the capabilities have expanded quite a bit since we put those up there, and I know we've been doing some recent work with this, but they support Docker, DCOS, and Kubernetes, which is actually a Google standard, and Mesosphere. Basically what this is Docker is a way, or containers in general, are a way to abstract an application. So you create an application and you create a Docker image which packages up everything involved in that application and makes it so you can host it. And you can say, okay, now I've got one up there and it's working, and now we have a whole bunch of customers, let's span this up, and you just tell it, okay, now give me 1,000 of these. And it will spin up 1,000 instances. But the other thing with containers versus like a VM is that they can put multiple containers on the same VM. So it costs less to host an application than it does to host a VM because of the complexity, or the density, that's the word I was trying to think of, the density level that they can achieve. So they pass that savings on. But it creates an isolation boundary around your app rather than at the server level. So if you do everything as VMs, everything is isolated at that VM level, and any isolation internally to that you have to manage yourself. With containers, each instance of that container running on whichever machine is totally isolated. So for instance, let's say you touch something in the registry. Each container has its own copy of the registry, and the operating system makes it totally isolated so that they don't affect each other. Let's see. Okay, the other thing that containers provide that is of a lot of benefit is some customers may end up saying, okay, we don't want to rely on one vendor. So you get situations like the AWS Virginia data center going down and taking out a whole bunch of broad services on the internet. So that's caused people to say, well, let's put our infrastructure up on multiple cloud platforms. So if you've containerized your infrastructure, you can take that same container and put it to both AWS and put it on Azure, and you don't have to do anything different about them. So it's an easy way of moving applications and their whole infrastructure around them as a component. Now, what does DCOS, Kubernetes, and Mesosphere do? Those are tools to do this on a massive scale. So you have something like, you're putting up, one of the things was Titanfall when it came out. Day one, they came up with 1 million servers. So when you want to bring up 1 million servers, you don't want to sit there clicking. You don't even necessarily want a script that you have to run and change that number from 10 to 1 million. You want to have a much better interface for doing that, and that's what those things provide. Now, similarly to that are VM scale sets. So if you have the same kind of situation where you have a VM up there and you want to now scale that out to 1,000 servers, with scale sets, you put that VM in a scale set, and you say, now I want this to bring this out to 1,000. It will make 999 more copies of it and bring it up within a matter of minutes. Azure Stack. This is another one that a lot of people don't really know much about out in the industry, that is fairly new. Basically, the machines that Microsoft uses for Azure are not standard off-the-shelf machines. They have some custom components in them that are not available to the general public. One of the key features in Azure that is infrastructure behind the scenes, you don't know about it. All of their routing infrastructure is done in software on little boards that are in each computer. And they have a chip set in that separate computer that link all of the other Azure machines together. And they do all the routing in software, not through typical hardware routing. That's why when you say, okay, I want to take this and move it over here, it's almost instantaneous because it's all software-based changes. So what Azure Stack allows you to do, they took that hardware platform that they created, and then they went out to HP and Lenovo and Dell, I believe, and said, okay, here's what the Azure Stack requirements are. So what you can do is you can now go to these vendors and say, okay, I want an Azure Stack set of boxes. And you purchase it from them, put them in your own data center, in your own building, whatever. And when they come up, they automatically connect to Azure. And so you host them, but they're connected up to Azure, and you manage them through the same portal that you manage something that's in their data centers. So they just show up as new boxes that are available to you. So you can then have that warm, fuzzy feeling that I have control over these boxes. So that's really what Azure Stack is meant to be. Now here's a few other capabilities in the infrastructure as a service classification. I'm not going to go over. They're kind of typical cloud capabilities. So now we move on to the services that are under a platform as a service. And some of these can be in multiple, so I just picked one. So the one we were most familiar with is app service. So an app service is, like it says, a website, basically, that you say, okay, I've got this website, I've got it developed, and now I want you to host it. So if you're working in a .NET project, you just say publish, and in 2 minutes it's up and running. Now, the app service gives you a lot of capabilities over doing this as infrastructure as a service, where you put out a VM, you have to put IIS on there, or whatever your web server is, and you have to maintain that web server. In this situation with an app service, you give them that image, and you tell them, okay, I want to run this on one box, and this is the size of the box I want to run it on. So you don't have control over the box itself or have to control it, but you can determine what level of CPU and memory and all that kind of thing that you want to use, primarily because it affects your cost. So you determine what size box, and then at any point you can, basically with slider bars, you just move them and you can say, okay, now I want to move this up to 50 boxes. And in a matter of minutes, you'll have a web farm with 50 boxes. And you don't have to do anything. Where in a traditional infrastructure as a service scenario, you'd have to go out, either buy those boxes or have to go to your provider and say, okay, I need 50 more. And in 2 days, they get back with you and say, okay, now we've got them available after you pay X amount of money. And then you're also in an infrastructure as a service management structure. You're paying for that VM for the entire time it's up. Now with platform as a service, you say, okay, I've got end-of-month processing, or I know I've got some event coming up and I'm going to have 100,000 users going to my website. So you slide the slider bar in a day in advance or whatever you want to do in advance, and scale it up to 10,000 servers. And so that scales it up to 10,000. The event happens, and you go back up and scale it back down. Or you can have it do it automatically. But the issue with that is there may be some lag at the very beginning as things scale up quickly. I mean, if you have an event that occurs, and at this point in time, the person's going to make an announcement. You can see all these people on their phones doing something. You're probably going to pre-provision for that kind of a scenario. Whereas if it's just word of mouth, people finding out about it, you scale up as needed. The next one is Azure Functions. This is one that are serverless. A lot of people the big buzzword is around serverless. And with serverless, it's very similar to Amazon's Lambda functions, or Lambdas as they call it. There's no need to provision servers There's no infrastructure that you have to maintain. And the infrastructure automatically scales your function call, your infrastructure behind your function based on usage. So as you've got things that come in, and as that number increases on how many people are hitting it at any given time, it'll automatically scale it up for you, so you don't even know. One example where we're using Lambdas is in one of the projects recently where we have a whole bunch of IoT devices out in the field, and you've got 10,000 IoT devices that are hitting this thing constantly. That you're only getting charged for with the functions, you're only getting charged for the number of executions of it and the amount of memory that those use. And when I say number of executions, it's like 5 cents per million hits. So it's really cheap compared to if you put that up on your website and you had, you know, 1 million hits, you would have a lot more, because you'd have to scale the whole thing to be able to handle this really narrow spike. So Lambdas can provide you a way to handle those spikes in a more cost-effective way. But you can create the code for functions in C#, Python, PHP, Bash, JavaScript, batch files, and also PowerShell. So the next one is a bot service.
I've heard about Azure Functions that, comparing them to Amazon Lambda, that Azure Functions are much easier to troubleshoot, especially if it's written in C# or any .NET language.
The reason partially behind that is because what it's actually doing behind the covers is making an app service app, but only billing you for usage, the actual invocation.
So are you actually able, with an Azure Function, are you actually able to step through the code in Visual Studio on your developer machine?
A little bit that I tried, I think you can. The other thing that we're going to get into in here a little bit is using application insights to do something very similar, because you can use application insights to look at past logs of what has occurred, what acceptance has occurred. And I was really surprised by this. I had one of my services that's up, and it got an exception at one point. I actually clicked on the exception in the list, and it took right to the code. And I was like, this line. Well, okay. I'm going to use this in the future. So anyway, the next thing is bot services. And when you think of bot services, think of anything that is conversational, where you want to have an automated service interact with people on an automated basis, or where it's kicked off from a chat type service. So something like GroupMe or Facebook Messenger, Skype, Slack, Microsoft Teams, SMS, Twilio, any of those kind of things can be the source of a connection into a bot service. Another one I'm looking at using when you create a bot service that asks you, here's some templates of ones that we've already created. One of them was an FAQ. So you put in your data from your FAQ, your questions and answers, and it gives your user a chat window like on your website. They type in a question and it indexes all of your FAQs for you using some stuff we're going to cover in a little bit in the AI section of this. But it will automatically figure out what question would best answer this question that the user brought up. They don't have to match identically. They don't have to have the same terms. There's a lot of fuzzy logic that goes on in there. Anyways. Then there's service bus. This is one that we don't really use, and a lot of our apps tend to be kind of small, so they don't necessarily lend themselves well to this, but on the bigger size apps, when you have multiple components spread around the network doing different things that need to communicate between each other to complete tasks, this is a lot of queuing up things that are coming in, and you're like, okay, we need to handle this and this and this and this and this and this, and then something else later on is saying, okay, now let me delve into this and deal with them. Or you can have a whole series of machines behind it saying, okay, we're going to deal with this, and you can have them scale up based on how much stuff is in the service bus. So as something happens, some major event came in and you had all kinds of users dump information in, it could scale up and say, okay, we've got 100,000 things to process. Let's, bring up 15 machines and process all of these. So that's what Service Bus is. Service Fabric is it uses Service Bus actually. And what it is Service Fabric is used for hosting microservices. So if you break your monolithic applications down into little microservices, typically people write them using Service Bus, so you've got your workflow in a lot of these business applications. So you've got data coming in here, and this process needs to occur, and it moves it to this stage, or this happens, and half of them go here, half of them go there. Different workflow. So you have microservices that move the needle from point A to point B, and then they put their data back into Service Bus, and it keeps going. So it's a different system architecture that lends itself more towards scalability at the individual component level that needs the scalability. So if you've got one particular part that's being hit heavily, you can scale up that part of it without having to have the cost of scaling up the entire system to that level. This is a different architecture that is a little more cost effective. Then the traditional storage, blobs, tables, queues, and also hosted NAS devices. You can get those as platform as a service. Now, media services. This is another one. Once in a while we have occasion for this, but I haven't seen a whole lot of it, but I thought I'd bring it up anyways. So when you think of media services, think of the Olympics. NBC uses this heavily for doing the Olympics. So they will have all the cameras streaming it to Azure, and they will take the data in, store it, and transcode it into multiple different formats and bit stream levels and all that sort of thing. So it's not just creating or sourcing of that data, it's also how do you stream it out. So you have a video that you want to put up on the internet and put up on, not on YouTube, because YouTube does this for you, but you may want your own video hosted on the web, and each client has different capabilities of what bandwidth they can handle. So when you use media services to do that streaming, it talks with each individual client, and it knows what bandwidth they can handle, and it scales that video to their requirements. And you don't have to handle all of the technical mumbo jumbo of how to do all that with video processing, which is a pain. And then there's a few other CDN, Azure Search, Notification Hub. We do CDN quite a bit, but the other two we don't necessarily do all that much, but they're typical cloud. Next is software as a service. First one, it would be Redis Cache, Azure Active Directory. These are ones that people are familiar with. Key Vault, and the multi-factor authentication service. I thought of that recently on IAL when they were talking about that, because this is a capability that's there on Azure, and whether they wanted to use it for one reason or another, I don't know. Power BI is another one that we're using on Fork Lakes, and probably going to be using it on other ones. It's a service for doing graphical reports mainly, dashboards, that sort of thing, where you have a lot of data that changes and you want to show really nice reports. And it gives more capabilities than your traditional just, here's a graph. It's the user has more capabilities of saying, well, let me look at this a little differently without going outside the bounds. HD Insight, so if you're familiar with what this is, I'm going to throw out some terms, some people will know what they are. Basically, this is a managed cloud implementation of Apache Hadoop. So it's the data center, huge data type processing where you want to use something like Spark, Hive, MapReduce, or the Microsoft R server to query data in different ways. Now, databases. That's another one. This one could be put in IaaS, it could be put in software as a service. So up on Azure, they support currently SQL Azure, MySQL, Postgres, MongoDB, and a new one, Azure Cosmos DB. This one was recently released at the Build conference back in May, and We're going to go into that next as to what that is. But one of the things I wanted to cover on this, I was looking for in the documentation, I was mentioning this to Patrick this morning. One of the differences, like with SQL Azure as opposed to, let's say, RDS on Amazon, is when you put something up on SQL Azure, it automatically replicates it to 3 boxes behind the scenes, and you don't really know it. So the equivalent on AWS, you have to bring up 3 SQL servers and have it do replication. So there's a number of different cases like this where they're doing things to make things a lot more cost effective and a lot more stable. So if a server does go down, you don't have to necessarily worry about it inherently with a SQL Azure database. But now we're going to go on to what is the Azure Cosmos DB, because it's something I think we could use in some of the different situations that we come across. It is a NoSQL database. Kind of think of it as a document DB version 2, kind of. It's multimodal. In other words, you can put data in different forms, whether it's key value, columnar data, like a typical document DB, or as a graph structure. So you think of a LinkedIn or a Facebook and how they have information about their users, and it's all this graph. It doesn't necessarily fit well into a traditional relational database. So the graph databases are specifically designed for that kind of purpose. Under the covers, it's storing all of these in the exact same way. You just don't realize it under the covers. Now you're like, well, okay, everybody's doing this. What's different? One, it's globally distributed. So you put your data up there, and you saw that map earlier. You literally say, okay, I want it in that data center, that data center, and that data center. And in minutes, it's in all those data centers. And it automatically scales. So you don't pay for storage per se. You pay for usage of that storage. And as you query that data, they do whatever they have to behind the scenes to make that happen as quickly as possible. So they index it for you. They do all kinds of things behind the scenes. There's 5 different consistency levels. In a normal database, you'll normally have 2 consistency layers, which are the first and the last of these. You have strong consistency, which means when you put data in, if you've got it replicated to multiple, let's say, data centers. With strong consistency, that call won't come back until it's replicated to all 3 data centers. With eventual consistency, which is what Facebook uses for their board, for instance, with Cassandra, it uses eventual consistency. That's why you'll put a message on your Facebook page, and you may have 200 friends. What it's actually doing is taking that message and copying it 200 times, once to each of your friends. But it can happen whenever. And it can possibly not happen if something happens in between. And it doesn't really matter. Now, you do that same thing with lines on an invoice, and we just forgot about that. It doesn't quite work. So you want some other level of consistency. The one that is of particular interest is that middle one. It's session consistency. So you put that data in, and any transact or any action within that session is consistent. But then somebody on the other side of the globe pulling it may not get it for a little while. So it's with the eventual consistency, you could put the data in and then query it back in front and not get that data back, because it may not be to the server that you're requesting it from. And so they have different levels of consistency, and it basically depends on how quickly you want your writes to be versus your reads. And it gets into this balance. Now, the data is accessible in many different ways, many different APIs. There's, as it shows here, Node, Java, .NET, Python, SQL, Gremlin, which is specific to graph databases, Azure Table API, MongoDB, because you can actually just take a MongoDB, put it up in this, and use your same connection that you use to Mongo and get the data out of here. And Document API. Now here's where it gets interesting. With guaranteed SLAs, 99% guarantee that you're going to get writes coming back in 10 mil, or yes, reads in 10 milliseconds, writes in 15 milliseconds. With financial backing to those SLAs. So if they can't maintain it, you don't pay. And in fact, if it gets bad enough, they pay you. But, like they're saying here, median latencies are less than 5 milliseconds. So when you start talking about these level of SLAs, you start looking at, and not just the SLA, but these kind of time frames. It starts opening up, oh, well, we may want to use this instead of possibly even like a Redis cache or other tools that are available that we may want to. The advantage here is it's a lot more queryable than it is in a Redis cache or that sort of thing. So with those kind of SLAs, it makes this a quite intriguing product to look at. And here's the even better thing. It's 2 to 3 times cheaper than document DBs. When I saw that one, I was like, okay, I'm gonna look at this one. All right, let's get back up to a couple other things. Here we're going to focus on some of the developer tools that are available. The first one is Application Insights, which we mentioned earlier. It basically will instrument your .NET application and automatically give you metrics on how your application is working. What kind of errors are you getting? What kind of exceptions are occurring and in what situations? So you see a lot of there's a lot of advantages to it. So another product that they have out there in the SaaS environment is their Team Project, which is kind of the new name for the TFS source repository, and also their TFS project is a lot like what we use Jira for. The project management, the day-to-day, this got done, and they tie check-ins directly to tickets. So then you can go back and see, okay, what bugs occurred in this release and what check-ins were specifically tied to those. Then they have now, it's a fairly new thing, the MyGet service, which is hosted NuGet, NPM, Bower, Maven, V6 repositories that you can use. Function apps, which are similar to Azure Functions, except that function apps have a whole WYSIWYG user interface on the portal in front of it, so you're developing mainly workflow components without writing any code. And then API management. So this does all of your security. So when you have concerns about, let's say they want to make it Active Directory based security or some 3-factor authentication based, it will manage the user's credentials at the API level. So there's a whole system in there of how to manage that, the APIs and the user credentials behind it. Now let's get into some of the fun stuff, the AI tools. So this is what they call Microsoft Cognitive Services, and some of these things I think we could use in some situations, but a lot of them tend to be around video or images or text and speech are the main things. So vision, I saw in a recent, at the Build conference, they had a presentation where they had cameras around a construction work site, and they had specific tools that only certain people were certified to use, whether forklift or whatever. And so they saw a user go into or pick up a tool that they weren't supposed to be using, and it automatically notifies the foreman of the job site. Hey, this person, is doing something that you might be liable for. You may want to do something about it. So it can analyze video, and you can train it to learn what different things are, and it will track them. It even they had another one. It was a hospital, and a nurse basically was like, the patient came into the ER, and they're like, where's the nearest wheelchair? And it said, down the hall to the right on this hallway. And sure enough, because they had taught it what a wheelchair looked like, so it tracks all the wheelchairs and where they're at in the hospital, so they know where they need to get one if they need it really bad. Okay, now speech. They do both speech to text and text to speech and text to text in different languages. So translation. At the same Build conference, they had 2 people standing up on the conference, in front of the conference. One person was speaking Cantonese, one person was speaking Spanish. And on the screen they showed her phone, his phone, and something in the middle. So she said something. You saw her phone was translating it. In the middle, you saw it translated to English. And then you saw the same thing translated to text on the other side, and then it spoke Cantonese. So the 2 people were speaking between Spanish and Cantonese and didn't know each other's language. And it was a really impressive demo. So some of the things in there, they have the translator text API, which was involved there, the spell check API, so if we get into ones where we've got text where the user's putting in data and they want to spell check it. The Q&A maker is one I mentioned earlier that I was looking at. Knowledge exploration service, this one's a mouthful, but that one, basically you've got large, like an encyclopedia. It can actually scan over the data and you can do queries on the data and it indexes it and does all kinds of other nice things with that. Recommendation API, it tracks, this is mostly used for sales and marketing, tracking what the user is doing and giving you recommendations on what you might want to present to them. So, so the labs, the last one there, these are more kind of, that are in beta and they're trying out different technologies. So they have gesture controls, route logistics, so you can tell that's for, you know, logistics, like a UPS or FedEx is trying to figure out what's the best route to use, that sort of thing. So, any questions? There's a lot there. I know. Yes. Oh, yes. You were supposed to remind me about a question. So the question came up, how do you pronounce this? Is it Azure or what? And although everybody's like, well, it's just a color, so it depends on what language. But everybody at Microsoft that I've heard talk about it, and they even looked it up this morning, and Ballmer even said, no, it's Azure. It's not Azure, it's Azure. So that's the answer to the question.
So everybody all at once. Azure.
Veraday? Okay.
Anybody?
Like AWS or Azure or either services that are kind of,
No, because it keeps fluctuating so much. So as soon as they make a tool, it would change.
or just more maybe more of a guideline of you're looking at functions versus lambda versus, it seems like it's
So
hard
it depends
to.
on your usage. It's hard to give a generic tool.